Okay, so this is the key to number 44. So number 44, you're given two functions. F of x is equal to 2x squared minus 4x minus 5. So you're given this quadratic function. And then g of x is this linear function. G of x is equal to 6x minus 3. And in letter A, you want to find f of negative 3. So remember, you have two different functions here. You have f of x and g of x, and this is asking you to find f of 3. So to evaluate the function f, which is this function here, when x is 3. So remember what that means. That means you go to your function f of x, and wherever you see the variable, you substitute negative 3. So this becomes equals 2 times negative 3 squared minus 4 times negative 3 minus 5. And then you just use the order of operations to simplify this numerical expression. Remember, the order of operations, you have to do exponents before you multiply. So you must say negative 3 squared, which is negative 3 times itself. So negative 3 times negative 3 is a positive 9. 9 times 2 is 18, so this part's 18. A negative 4 times a negative 3 is a positive 12, and then you're subtracting 5. 18 plus 12 is 30, and then 30 minus 5 is 25. So f of negative 3 is equal to 25. All right, so that was letter A. Now letter B, remember this means 4 times g of negative 2. So what you have to do first is find g of negative 2. So we're going to find g of negative 2 the same way we found f of negative 3. I go to my function g, which is this linear function, and wherever we see the variable x, I'm going to substitute negative 2. So this becomes 6 times negative 2. In place of x, you're going to substitute negative 2. And then whatever that product is, you're going to subtract 3. So 6 times a negative 2 is a negative 12, and a negative 12 and a negative 3 is a negative 15. So all I found, though, remember, all you found was g of negative 2. So then you're going to come back here, and you're going to say, well, that's going to equal 4 times, and g of negative 2 is a negative 15. So don't make the mistake and say 4 times negative 2 is negative 8, because that's not mathematically, that's not correct. Okay. So then you use your calculator, and so you're going to say 4 times a negative 15 is going to give you a negative 60. So that equals a negative 60. And there's your answer. All right, so if it says show work, remember you got to show the work. So just don't come up with the answer. You got to show something that tells me how you got negative 60. Okay, so now we're going to start talking about the algebra of functions. So remember, the algebra functions are those operations: adding, multiplying, subtracting, and dividing. So you have your quotient, your difference, your product, and your sum. So remember, f plus g at 2, remember that does not mean distribute here. Okay, so that's not what that means. But f plus g evaluated at 2, and always write it in the order going from left to right, especially when you're dealing with subtraction. The order does matter. So by definition, this is going to be f of 2 plus g of 2. That's what that means. So then we're going to go off to the side, and we're going to figure out what f of 2 is, and then we're going to figure out what what g of 2 is, and then I will add them up. All right, so f of 2. So remember, f of 2, you can do it just like you did letter B, just like you did g of negative 2. So you can go to your function f, and where we see the variable x, you're going to substitute 2. So I get 2 times 2 squared minus 4 times 2 minus 5. And then 2 squared, you do the exponents first, so that's 4. 4 times 2 is 8. And then negative 4 times 2 is a negative 8, and then minus 5. 8 minus 8 is 0, and 0 minus 5 is a negative 5. So f of 2 is negative 5. So right here, I'm going to put negative 5. Then we find g of 2. So g of 2, then, you go to your function g, and where we see the variable x, you substitute 2. So this becomes 6 times 2 minus 3. So that's 12 minus 3, which is 9. And so g of 2 is 9, so I get negative 5 plus 9, which is a positive 4. So what I found is this. I found f plus g at 2 equals a positive 4. Okay? All right, now here's a product. So remember the closed circle is a product. So that becomes, I can write this as g of 5 times f of 5, right? And then we do all the work. So we got to find g of 5 first, find f of 5, and then we're going to multiply those. So g of 5, let me go ahead and kind of separate those somewhat. All right, so g of 5 will be, so I go to my function g, and wherever I see the variable x, I substitute 5. So I get 6 times 5 minus 3. 6 times 5 is 30. 30 minus 3 is 27. So g of 5 is 27. Okay? Then I got to find f of 5. So f of 5 means I go to my quadratic function, and wherever we see the variable x, I substitute 5. So I get 2 times 5 squared minus 4 times 5 minus 5. Well, 5 squared is 25. 25 times 2 is 50. A negative 4 times 5 is minus 20, and then minus 5. 50 minus 20 is 30. 30 minus 5 is 25. So f of 5 is 25, so that goes here. And then you find the product. Use your calculator. Obviously, you're probably going to need your calculator for that. 27 times 25. So when I use a calculator in that, 27 times 25 will give you 675. So you can say g times f at 5 equals 675. All right, letter E. All right, letter E. This time you're subtracting. Now remember, when you're subtracting, the order matters. So since g is listed first, you're going to say g of negative 4 first. So that's going to equal g of negative 4 minus f of negative 4. And so just like we did before, we find g of negative 4 first, then we find f of negative 4, and then I subtract them. So let's find g of negative 4. So g of negative 4, I go to my function g, which is this linear function, and wherever I see the variable x, I substitute negative 4. So I get 6 times negative 4 minus 3, so that's negative 24 minus 3, which is a negative 27. So this is a negative 27 right here. Then we're going to find f of negative 4. So f of negative 4, I go to my function f, which is this quadratic function, and wherever we see the variable x, I substitute negative 4. So I get 2 times negative 4 squared minus 4 times negative 4 minus 5. Negative 4 squared is 16. 16 times 2 is 32. A negative 4 times a negative 4 is a positive 16, and then minus 5. 32 plus 16 is 48, and then 48 minus 5 is going to give you 43. So f of negative 4 is 43. So that goes here, 43. So a negative 27 and a negative 43, that's a negative right here. A negative 27 and a negative 43, use your calculator if you have to, is going to be a negative 70. So therefore, we're going to say g minus f at negative 4 equals a negative 70. Okay, and then we have the quotient here, the division. So g is in the numerator, so make sure you put g in the numerator. So that's g of negative 5 divided by f of negative 5. All right, so let's go ahead and figure out what g of negative 5 is. So g of negative 5, so remember you go to your function g, which is this linear function, 6x minus 3, and in place of x, you're going to substitute negative 5. So you're going to say that's going to be 6 times negative 5 minus 3. 6 times negative 5 is a negative 30, and negative 30 and negative 3 is a negative 33. So that's the numerator. Okay. The denominator, f of negative 5, so I go to my function f this time, which is the quadratic function. Wherever you see the variable x, you're going to substitute negative 5. So in that case, you're going to get 2 times negative 5 squared minus 4 times negative 5 minus 5. Negative 5 squared is 50. I'm sorry, 25. 25 times 2 is 50. So you get 50. And then a negative 5 times a negative 4 is a positive 20. And then minus 5. 50 plus 20 is 70. 70 minus 5 is 65. So 65 goes here. All right. And then reduce if you can. Now this is not reducible, but you do want to reduce if you can. But that's the answer. All right, so you have this proper fraction that's not reducible, or that cannot be reduced. Okay, so that was number 44. Okay, so notice in 44 you evaluated. See the algebra functions part here. You evaluated those two functions at a number. You ended up with a number 4. You multiplied those two functions at a number. You ended up with a number with a numerical answer. Same thing here. Okay. So in number 45, though, you're evaluating those functions at the variable x. So you're going to end up with a variable expression as the answer, not the number. Okay, so just like we did in the previous problem, f plus g at x means f of x plus g of x by definition. And then notice the difference is that in the previous problem you had quite a bit of work to do, didn't you? So you had to go into these functions up here, and you had to substitute some numbers into those variables, and there were quite a bit of order of operations that you had to perform. In this one's a little different because you're not asked to evaluate it at a particular number. You're just asked to add those two functions together. So basically you say, well, I know what f of x is. F of x is this binomial right here, this linear function. So that's just 2 minus 5x plus, and I know what g of x is. G of x is this quadratic function, this binomial quadratic function, and so I get 3x squared plus 2x, right? And so therefore, when you combine like terms, and let's put them in descending order, we're going to put it 3x squared first, so you get 3x squared. A negative 5x and 2x is a negative 3x and plus 2, right? Positive 2. So therefore, you would say f plus g at x. So when you add those two functions together, you get this new function, which is 3x squared minus 3x plus 2. So the algebra functions means that when you given functions, you can combine them to get a new function. And that's what we're doing. We're adding these to get a new function. We're subtracting these to get a new function. We're multiplying these to get a new function, and so on. All right. But notice that evaluated at the variable x, I ended up with a variable expression. Now over here, just like with the previous one, subtraction, you have to be careful. Make sure you put it in order. So that's g of x minus f of x. All right, now g of x, remember, is this function. So g of x is equal to 3x squared plus 2x. Okay, now with subtraction, you need to make sure, see that's subtraction, right? You need to make sure you put that function f of x in parentheses. With addition, I did not have to because I was just adding that function to it. But here I'm subtracting, so subtracting means you got to subtract all those terms. And every term of f of x, there are two of them. You have 2 minus 5x. So when you're subtracting, you basically are adding the opposite of those terms. So basically that means 3x squared plus 2x. The opposite of a positive 2 is a negative 2. And the opposite of a negative 5x is a positive 5x. And then combining like terms and putting descending order, you get 3x squared. 2x plus 5x is 7x, and then minus 2. And that will be your answer when you subtract those two functions. You get this new function, which is this. So g minus f at x is equal to this new function, which is equal to 3x squared plus 7x minus 2. Over here you're multiplying, so by definition that is f of x times g of x. And then now notice you're multiplying functions, so you got to put those functions in parentheses. Well, f of x is this right here, and g of x is this. So f of x is 2 minus 5x, and then g of x is 3x squared plus 2x. And notice I put those in parentheses. Because if you didn't put in parentheses, then the only thing that technically those do not have parentheses, you're only multiplying these two terms here, right here, and that's not true. Okay, so let's go ahead and use the FOIL method. I have two binomials, so I can use the FOIL method. The first 2 times 3x squared is 6x squared. The outer 2 times 2x is 4x. the inner, a negative 5x times a positive 3x squared is a negative 15x cubed, right? X times x is x times x squared is x cubed. And then last, a negative 5x times a positive 2x is a negative 10x squared. And then going ahead and putting that in descending order and combining like terms, I have a negative 15x squared, x cubed, 6x squared, and a negative 10x squared are like terms. 6x squared and a negative 10x squared is a negative 4x squared. And the only term you have left is plus 4x. All right, so f times g at x is equal to negative 15x squared minus 4x, 15x cubed minus 4x squared plus 4x. All right, now 46, notice this is an open circle. So remember, open circles, those are compositions. So you have to be careful. That's not multiplication. So by definition, f composed with g at negative 3 means f of, so that's where you're putting a function inside of another function. So you're saying f of g of negative 3. So basically you're taking g of negative 3 and you're putting it inside of the function f. That's what this says. So then to evaluate this, I've got to go off to the side and I got to figure out that innermost function. So I got to figure out this part first, g of negative 3. So g of negative 3, so remember g of x is this quadratic right here. So wherever I see the variable x, I substitute negative 3. So I get negative 3 squared, put that in parentheses, minus 3 times negative 3, and then plus 4. Negative 3 squared is 9. Don't say it's negative 9. Negative 3 times itself, that's why you have to put that in parentheses, is a positive 9. So I get 9. Negative 3 times a negative 3 is a positive 9, and then plus 4. So I have 9 plus 9 is 18, and 18 plus 4 is 22. So this part, now be careful, all you found was g of negative 3. So now, notice the steps. Notice how I'm writing the steps. It's in a sequential order, and it makes sense. And so you're going to say f of, now remember I just found this, that's this, so there's my work. So now you're going to find f of 22. And then f of 22, I go to my function f, and wherever I see the variable x, I substitute 22. So this is going to become 5 times 22 minus 1. 5 times 22, if you don't know it, use your calculator. So you're just going to say, it's very easy to use a calculator, right? You just say 5 times 22, and you get 110. So this is 110 minus 1, which is 109. And there's the answer. So what I found is that f composed with g at negative 3 is going to equal 109. That's what I found. Notice I composed a function at a number. I ended up with a number. Here I'm composing a function at the variable x. I'm going to end up with a variable expression. So let's look at this one. So by definition, just like we did this, this means f of g of x. That's what that means by definition. And then I go now and I look at the innermost function. So the innermost function is g of x. I know what g of x is. That's this right here. That's this quadratic function. So I get f of x squared minus 3x plus 4. So that is this. So that what this means now is I go to my function f, and wherever I see the variable x, I substitute that expression right here. So that becomes 5 times, and then I substitute that trinomial, 5 times x squared minus 3x plus 4, and then I subtract 1. Distributing those three terms, multiplying those three terms by 5, I get 5x squared. 5 times a negative 3x is a negative 15x. 5 times 4 is 20, and then subtract 1. So that becomes 5x squared. A negative 15x, that's the only term that involves the factor of just x. And then the constants, 20 subtract 1 is a positive 19. And there's the answer. So you're going to say f composed with g at x is this variable expression, 5x squared minus 15x plus 19. All right. Okay, and so in the other problem, you were also dealing with compositions. All right, all open circles, compositions, but this time you're looking at it in terms of a table. Okay, so let's look at that. It's not difficult, fairly easy. Notice that I'm evaluating all those functions at numbers, so I'm going to end up with numbers. I want to find out what does this equal to, what is that equal to, what is that equal to, and so on, right? So I want to know when I take f and compose it with g at -1, what is that value? All right, so let's do the work here. So let's look at part A. So part A, so we have f composed with g at -1. By definition, that means f of g of -1. So if you compare it to what we did here, right here, so to find g of -3 in this one, I had to go to my function g, right? And I had to substitute wherever saw the variable x, I had to substitute -3, and that's what you see here. Then once I find that, then that's what g of -3 is, which is 22. Then I go to my function f, and this time I substitute 22, and I get 109. The difference here is that when you're finding the innermost function, you're actually looking at the table, and you need to know how to read that table. Reading that table is important. So remember, g of -1 means what's the y value when x is -1. So first of all, I got to find x equal -1. That's this right here. So I want to say, remember, g of x, f of x, think of those as y. So what is my y value when x is -1? You got to make sure you choose the right one. Now in this case, they're both the same, so you could have made a mistake and gotten the right answer, right? Okay, but remember, g of -1, you go to your g of x column, and when x is -1, that's your y value right here. That's the one you're going to use. So g of -1 is 3. So now I'm going to find f of 3. So f of 3 means I go to my table, my f of x column, and when x is when x is 3, I find out what my y value is. So when x is 3, f of 3 is -2. So that's -2. So what that means is that f composed with g at -1 is -2. Then you do the same thing with b. So in b, you have g composed with g at 2. So by definition, that means g of 2. Notice the notation. Notice how I wrote it. G parentheses, G parentheses 2, close parentheses. So you always do the innermost first, g of 2. So remember, g of 2 means I go to my g of x column, and when x is 2, I find out what that y value is. So there's your x. These are your y values. Remember, f of x means the same thing as y. All right. So g of 2, so here's x equal 2. G of 2 is 0. You got to make sure you use the right one. G of 2 is 0. So this becomes g of 0. So now to find g of 0, I'm still in my g of x column. I want to know what is that y value when x is 0. So here, well, I don't have a 0, do I? Okay, so let's go ahead and change that. Let me make sure I do this right. So g of 2 is 0. And so g of 0, I'm going to make a little change here. Okay, make a little change. So g of 0, let's put 0 right here. G of 0 is, let's say, 7. Okay, so you're going to say equals 7. Now, technically, you could have said does not exist. You could have said that, but I'm going to make sure that those numbers do exist. So g of 0, you could have said does not exist, but that's not what I wanted. That is not what I wanted. I actually wanted a number there. So I'm going to go back in the study guide, and I'm going to go ahead and make a correction on that table. All right. So g of 0 will be 7. All right. Just make sure I did this correctly. I wrote down the number correctly. G of 2. So g of 2 is 0. There, and then I want to find g of 0. There was no x equals 0, so I had to put 1, is 7. All right, so that's going to be 7. All right. Okay, so let's find the next one. So C, you want to find f composed with f at -2. So by definition, that means f of -2, right? So let's find f of -2. So f of -2 means I go to my f column, my function f of x column. And what's that y value when x is negative 2? So when x is negative 2, that y value is 4. So this is 4 right here. So now I've got to find f of 4. And so f of 4 means what is that y value when x is 4? Well, that y value is 6. So this is 6. All right. Then D, so let's look at D. So D, you want to find f composed with g at negative 2. So by definition, that means f of g of negative 2. G of negative 2, so there's my g column. Negative 2, g of negative 2 is a negative 1, right? So that becomes f of negative 1. And then f of negative 1 means I go to my f column and I find out what's that y value when x is negative 1. Well, my y value is 3, right? So you get 3. So 3 goes here. Then the last one, g composed with f at negative 1. I'm going to do the work here. So g composed with f at negative 1 means g of f of negative 1, right? So f of negative 1, so I go to my f column, and when x is negative 1, I get 3. So then I got to find g of 3, right? And so g of 3 is going to be a negative 8. So that equals a negative 8. That goes here. All right. Okay, so I did have to add a column going through this, and basically I can make this, let's say, negative 10. We didn't even need this anyway. So that's it. So that is problems 44 through 47.